So for these practice problems, you may need a calculator, and then you will be able to work out the rest of these in your notes. There will also be some questions where you will get to try some on your own. Make sure you're answering the questions throughout the video so that you can help evaluate yourself on how well you're understanding the information. And as always, if at any point you need help, please raise your hand and ask so we can go over it together. So let's look at the first practice. Okay. Anytime we're doing anything with reactions, remember we always want to start by just balancing our equation. So we're going to kind of do a little bit of practice of that throughout these notes because you're going to have to do that on your test and on your quiz. And then also just every day in class anyways. So this is just good practice to make sure you're staying on top of things and on the same page. So when we're balancing equations, right, our first step is just to count how many we have. We want to make sure we have the same number on both sides. So if I start, I'm just going to look at magnesiums first. I can see I have one magnesium on the left, one on the right. So those are balanced. The next thing I'm going to look at is oxygen. On the left, I have two oxygens, and on the right, I only have one. So the best way that I can balance that is I want to have 2 and 2. So I'm going to put a 2 in the front of this oxygen. And what happens now is I also have 2 magnesiums, because remember, this is 2 of that entire molecule. So now I need to put a 2 on the other side so that everything is balanced. So now if we look, we have 2 magnesiums on each side and 2 oxygens on each side. Remember, we do not have to write this invisible 1 here, but if that helps you to kind of visualize what you're seeing, that is totally fine if you put that number there. Just remember, you will not always see a 1 written there in any equations that are given to you in any practice questions. So let's look at the reactants that are given to us. We have 2 moles of magnesium and we have 2 moles of oxygen. So I'm just going to write those kind of down below. So we have 2 moles magnesium and 2 moles of oxygen. So if I think about it, right, in my some more scenario that we were looking at earlier, right? There's kind of 2 ways we can think about it. We can reason with ourselves, or we can just do a simple division. So in my equation, it tells me that I need 2 magnesiums for every 1 oxygen. So if I think about, okay, I have to have 2 magnesiums to do this equation 1 time. So if I'm given 2 magnesiums, that means I can only complete this reaction 1 time, right? However, for oxygen, I only need 1 oxygen, 1 mole of oxygen. I'm given 2 moles of oxygen, so that means I can complete this reaction 2 times, right, with what I'm given. The other way to do this is just a very simple math calculation. We just take what we're given, so I could take that 2, and I'm just going to divide it by whatever number is in my blank or my coefficient. So 2 divided by 2, again, is just going to equal 1. In this case, 2 moles of oxygen divided by 1 is just going to equal 2. Okay, so what does this tell me? It tells me that magnesium, I can only do the reaction 1 time, and with oxygen, I could do the reaction 2 times. So which one is limiting the number of times I could perform this reaction, or how much I could make? Right? Well, the answer is magnesium, right? Because I'm going to run out of magnesium after the first reaction, I can't do anymore. So magnesium is my limiting reactant. Let's look at another example. Okay, so in this case, we're using the same equation. We've already have the balanced equation written, so we're just going to look and see what are we given. We're given 5 moles of magnesium, and we're given 2 moles of oxygen. So let's look at magnesium first. I have 5, and I know that for each reaction I need 2. So again, we can do this kind of thinking Well, if I have 5, right, I know that the first reaction is going to take 2. The second reaction is going to take 2. So after that, I'm only left with 1 mole of magnesium, which is not enough to do this reaction, right? So I can only perform this reaction 2 times with my magnesium. Okay, so again, we could do a simple math. We could say 5 divided by 2, right? This number divided by this number, and that's going to equal 2.5. So I could perform this reaction 2.5 times, right? For oxygen, I have 2 moles. I only need 1 each time. So that means oxygen could perform this reaction 2 times. So which one of these is the smallest number? So since oxygen is the smallest number, that means oxygen is limiting the reaction. So oxygen is the limiting reactant. I only have enough to do the reaction 2 times. Okay, let's look at one more. This time, okay, I'm given grams. Not the end of the world, right? But in order to do my limiting reactant, I have to have moles. So the first thing we're going to do, right? So again, we always know we have to have a balanced equation. And then we always want to make sure we're comparing moles, okay? Because that's what these numbers here are, right? And then including my little invisible one, those are my mole ratios. That's telling me how many I need, how much I need for each reaction to take place. So let's look, and we're just going to write down what we're given here. So 15.9 grams of magnesium, and then I have 12.8 grams of oxygen. Okay, so remember, how do we go from mass to mole? Well, I know that 1 mole I can convert to grams by using the molar mass on the periodic table. So I'm just going to grab my periodic table. I'm going to do this in a different color, right, so we can kind of see. So my mass of magnesium is 24.31, and then my mass of oxygen, remember 1 oxygen is 16, but I have 2, so that's going to be 32 grams. So then if I take my calculator and I say 15.9 divided by 24.31, that's going to give me 0.654. And then for oxygen, 12.8 divided by 32 gives me 0.4. Okay, so now, right, our last step, now I have the moles that I'm given. Okay, so now we need to see, okay, well, which one is going to be able to perform the most reactions? So now that we don't have these pretty numbers, right? Remember, we can always take our number of moles and then we can just divide. I'll grab another color here. Divide by this number, our coefficient in our equation, right? Because I know that each reaction is going to take 2. So if I divide and see how many I have enough for, that only gives me 0.327. And then this gives me 0.4. So which one of these is smallest? That would be this number. So my magnesium is my limiting reactant. Let's look at one more equation. So I want you to take a minute and try to see if you can balance this equation yourself, and then you can replay the video and check your answers. Okay, so let's start by just looking at carbon. Okay, so I have over on this side, I have 1 carbon, and over on this side I have 1 carbon. So those are balanced. We're looking good. Over here I have hydrogen in 2 different spots. So I have a hydrogen here and I have hydrogen here. So that means I have a total of 6 hydrogen. On the right side, I just have hydrogen in 1 spot. So that gives me 2. For oxygen, I just have 1, and then I have 2. So just a hint to maybe help you in the future, because this hydrogen right here is by itself, it's not bonded to anything else, no different elements. A lot of times I usually save my hydrogens and oxygens for last, especially if they're by themselves, because they're easy to fix at the end. So let's skip over hydrogen for now and let's look at oxygen. I only have 2 on the right side. I only have 1 on the left side. So that means I need to put a 2 there. And now I need to take another look at my hydrogens. So again, remember we said we have 4 here, but now in this space we have 2 water molecules. So I have 2 H2s. So that means I have 4 hydrogens. So my total number of hydrogens is now 8. So if I look back on the right side, I need to make 8 hydrogens. The way I can do that is add a 4. So now everything is balanced, and now we're ready to move on to the actual question. So I'm just going to erase my work here so it doesn't get confusing. Remember, we'll put little ones there, right, just to kind of help us remember that those are invisible, but they are there. So let's see, my question says that I have 2 moles of CH4 and 3 moles of water. So let's think about it. How many reactions can I do, right? Well, remember, we can always very quickly figure it out by just dividing by the number in the blank, divided by 2. And then now we can just say which is the smallest. So since this is the smallest, I know that water is the limiting reactant. Okay, and again, we can think about it conceptually for, let me kind of signal this one, right? If I have 2 moles, but it only takes 1 mole for each reaction, then I know I can do this reaction 2 times. For water, I need 2, but I only have 3, so I know I can't do the reaction twice, so it has to be the limiting reactant. So for this problem, remember we already have our balanced equation. So I have 6 moles and 7 moles. I want you to take a second to see if you can figure out which one is the limiting reactant. All right, so for my CH4 methane, right, I only need 1 for every reaction, so that means I can have a total of 6 reactions. For water, I need 2 for each reaction, so that's only going to give me 3.5. So which one is my limiting? Water, because it's the smallest number. All right, last one. Again, this has grams, so remember our first step, right? We have to be in moles in order to compare our limiting reactants, right? So we're going to look at 6.34 grams of CH4 and 8.90 grams of water. So remember, in order to go from grams to moles, right, we have to use our periodic table. So in this case, CH4, I have to add up 1 carbon plus 4 hydrogens. For water, I have to add up 2 hydrogens and 1 oxygen to get the molar mass. And then now I'm ready to just divide. So for CH4, I divide 6.34 divided by 16.05. I get 0.395. And then for water, 8.9 divided by 18.02. And that equals 0.494. So now that I'm in moles, now I can start comparing my limiting reactant. Remember, the easiest way is just to take it and divide it by whatever number is in that spot right there. So for water, we would divide by 2. So we just look and see, okay, which one is the smallest? That would be this one. So this is my limiting reactant. And I will admit it does get a little weird when you start looking at grams because our moles are not these pretty numbers. Okay, so one way to think about it is just, I think dividing by your coefficient, right, our number in the front, is kind of an easier way to go about finding the answer. Just because it's hard to sometimes compare when we have our decimals in moles. So now it's your turn to try some practice problems on your own.